guys ready?
Yeah.
Sounds good. Hi everybody, my name is Mitch Seal. I'm here at EOU, hoping to graduate, and I did my capstone presentation on road salt preference. The basis of my whole project was here in Oregon. We started using road salt last winter, and it was kind of hotly debated. There were a lot of people that were really upset about it, and they cried mutiny, and they didn't want their cars destroyed, which is a byproduct of road salt. And there were people that said, this is the best thing on earth, we need it. We had a bad winter 2 winters ago, it kind of put people on edge, and they were looking forward to the road salt, hoping to keep the roads open for longer. And so the issue was hotly debated, and that got me thinking, I wonder if I can figure out who will vote yes on the road salt issue if it were to come up again. Or predict who did vote yes on it back then. So I set out to start studying it, and I came up with a couple of variables that I thought were important, and those variables are a person's income, how many miles they drive per year, and how they value their vehicle. If you really prize your car, maybe you will or won't approve it because you don't want to crash it, but you don't want to destroy it. And so I set out to run a regression based on those to try and find correlation. So my methodology, my process began by administering a survey both here on campus and out in the real world. I sent out a bunch of surveys to various economics students in here. They were voluntary. Nobody had to fill out anything. Most of the students were kind enough to submit surveys. And then I went down to a local oil change business where people were in the waiting room, and I left some surveys there for a week and a half so those people could fill them out too. I go over my findings a little bit later, but that was how I collected my data, was primarily through surveys. And once I had the data, I put all the data into a spreadsheet, and I had to go on a quest for the right kind of regression to get the best results that fit the model that I wanted to use. What I ended up coming up with after lots of study was a multiple logit regression. Now this is like a regular regression. I'll go into it a little bit later, but the basic thing that makes it different is that instead of coming up with just some number, it comes up with a probability that something will occur. So it gives you an answer between 0 and 1. It's almost, well, it is a decimal point. And that tells you your likely probability within a certain confidence interval that something will happen. So I found that that was going to be the best solution to analyze my data. And from there, you can also get coefficients and p-values off of each independent variable. And so I was able to use the coefficients to generate marginal rates of change to show what actually is going on, and p-values to show how significant they are. This is my official equation. As you can see, it looks like a standard linear regression. It's a little bit funky looking. P is probability, which is your outcome. It's a function of beta 1, which is just an intercept. We have household income, we got the mileage variable, the personal valuation of a vehicle variable, and I added 2 dummy variables into there as well. This one labeled PK is previous knowledge. I thought maybe if you were educated on the subject or had heard about it before, you'd probably be more likely to feel one way or the other. But I primarily threw that variable in as a thing in my survey, so that if you didn't know anything about it, you weren't biased by the survey if there was bias that came back afterward. Luckily, I think I wrote my survey pretty well. As I show in my results later, that variable was significant, but I'm not sure if it was because of my survey. And then because some of the data came from students on campus, and we can assume that most of the data that came from the surveys at the oil change station were not students, I wanted to put that dummy variable for student collected at the school just to make sure that there wasn't some bias going on just from being a student at school. The other thing that I did as I was running my multiple regression is I found that I was having a little bit of trouble interpreting the results, and I decided it might be a good idea to run an alternative test on the data. So I used a simple chi-square test just to see how that was going to, what it was going to give me, and maybe it was going to make more sense, or maybe it was going to disprove the linear or the logit regression results. It turns out they lined up somewhat well, somewhat not. Like I said, I'll go into that later. As a result of my survey, I was able to collect 68 total surveys. 54 of them came from the school, so a majority of them came from the school. It's a little disappointing. That would be a thing to do if the test was run over again. And 14 of them came from the oil change location. Of those 68 surveys, I asked people at the very end of it whether they approved of road salt usage or not, and 42 approved of it, and 26 did not. So about 2/3 of people are on board with it, and 1/3 of them were not. Just looking at the surveys through the pile, the people that were not on board with it were really not on board with it, which is a kind of interesting finding. These are the results from my regression. They look a little bit different, and I had to format them in a table because they don't look like a standard regression output. But long story short, I've labeled my p-values for each variable, and I've labeled the coefficients here. And I ran 3 separate regressions. I decided to run one on all of the data, and then just to see if there was some trend going on with either the student collected data or the data from the oil change station, I ran regressions with just that data. Now, as you can see, I want to focus on the oil change data for a moment. There were some problems with that. As you can see, there's a couple of 0.999 p-values, which is about as mathematically high as a p-value can possibly be. It's about as not significantly significant as possible. So that data, combined with the fact that there was only 14 surveys to pull from, tells me that the data is just, there's too few of it, they're too weirdly correlated, and that's why we're seeing weird statistical phenomenon. But it's also why these results have to be taken with a huge grain of salt. The student data, on the other hand, looks a lot more predictable. As you can see, we've got a couple of nice small p-values in there. There's a 0.1, there's a 0.094, and we see some really big ones too, 0.728, 0.78. These household income and vehicle valuation for students in particular were really not significant, but not so insignificant as to throw up a red flag and say, well, that's almost mathematically impossible. Why is that going on? And as you can see, the total data, if you spend some time looking at it, is pretty heavily influenced by the oil change data. Even though there was only 14 surveys, it definitely tampered with it. I'll go in my next slide to explain why that's a problem. But overall, the ones that I want to point to the most is the intercept is obviously significant for students. Mileage driven is considerably significant for both the total data and the student data. And previous knowledge is the only other variable that had any significance with any of my tests. So the other thing that I mentioned earlier, I ran a chi-square test separately to see what I got, and this compares the results. Interestingly enough, on my variables that I found significant from the regression, they lined up pretty well with what I found from the chi-square output. We got a p-value of 0.118 on previous knowledge, and according to my statistics textbook, chi-squared outputs should be close to a p-value generated by a regression. I estimated the chi-square table, or based on the table, to be 0.25, but I could be off, could be a little bit lower than that. It's hard to estimate. Same thing with mileage driven, between a 0.14 and a 0.15. Those are pretty similar. These other variables did not line up. I don't know why that is. I don't have time to look into it, but that would be a good continuation of the study to examine why these are so different. And the other thing that you can do, that I did do, is using the regression's outputs for coefficients, you can determine marginal change rates. And that's where I really got some interesting results. To do so, you simply take the coefficient that comes off of it. For example, here I've got, from all of my total data, I've got my mileage driven coefficient, which is negative something, 0.423, very small. And that basically tells you how likely the probability is to change for every mile driven. But people drive lots of miles, so if you multiply it by 1,000 and work that in, what I found was that for every 1,000 miles that you drive, it's negative. So you are likely by 4.23% to disagree with road salt usage. And that's per 1,000 miles. Once again, people drive even more miles than that. And as I went into in my paper as an example, if you were to drive 14,000 miles instead of 8,000, which is not unfeasible, that's a common thing, people drive different amounts, that puts you about 25% less likely to agree with road salt usage. So the amount of miles you drive in real life actually does have quite a bit, according to this, with how you might feel about it. I did the same process for previous knowledge because it was the only other variable that showed any statistical significance in the first place, but I did run into some problems, as I mentioned earlier. As you can see, the p-value for the oil change data is 0.999, and it has this coefficient which is just off the charts of a negative 21 point something, and that's in a field where the other coefficients are right around 1. So seeing the 3 values all next to each other in this table, I realized that this probably means nothing significant, and it's really dragging down or influencing the total data. which is why when I did the same process, I actually used student data, even though it probably would have been better to use the total data. The student data looked like it had a good p-value, and it looked like it was reasonable given the circumstances. And so using that to make a marginal rate, I was able to find that, I have it on my next slide, yep. So if you know about road salt and ahead of time you're educated on the issue, you're 9% less likely to agree with it, and that's at a p-value of 0.16, so there's an 84% confidence interval there. Not perfect, but more significant than really anything else I found in my survey. So in conclusion, with my project, I found that a person's income, which really surprised me intuition-based, does not have anything to do with how you might feel about road salt usage. The only variables I could find that maybe pointed one way or the other was your previous knowledge of the issue, are you educated on it, and how many miles you drive. Both of them were negatively correlated. As that goes up, your likelihood to vote yes on road salt usage goes down. That's what I found mathematically. Like I said, perhaps the most interesting thing was that a person's income didn't. I was waiting for income to go up and preference to go up or down, thinking rich people would either use safety or their vehicles more. But I didn't find any of those correlations, so that was a surprise more than anything else. And at the end of it all, what can this data be used for? Well, it's a little bit vague, but if you're a political campaign and you're looking to capitalize on this issue, if knowledge affects people's viewpoints on it, knowledge is your friend, one way or the other, whichever you're trying to influence. If you're trying to lead a political campaigns, trying to banish road salt from the earth, you're probably going to want to drive home with people how bad it is for your cars, or if you're trying to push it, you're going to want to push safety figures because that knowledge is going to be good for advertising campaigns. I can't think of too many other examples you might want to capitalize on this information. The best I could come up with beyond that would be if you're trying to market car care products. We do see this here in La Grande, Oregon. The oil change station that I went to capitalized on it last winter. They offered undercarriage washes to protect your paint. They sold a ton of them. They boomed because of it. And for businesses like that, just keep pushing your advertising, keep pushing how bad this is, and people will come because they're influenced. Beyond that, if you can target people based on how many miles they drive, that's a lot more difficult, but that's another really good way to target people with the most significance. Last but not least, thank you, Scott. Thank you, Peter. Thank you, everyone, for all of your help on my project. It's been a great ride here at EOU. And with that, are there any questions?
Time for one quick question.
So I guess this is more of a comment. I think with the income piece, if it's not significant, you're probably having an equal number of people that are on both sides of the fence on that, which fits my anecdotal experience. Back in Michigan, there are people on both sides. Obviously see the safety factor, but then there are plenty of people complaining about what they're doing to their cars. Although an additional variable would be maybe time, like looking at how road salt protection has improved immensely over the last 20 years. It used to be in the Midwest, in a number of years, you had no car left.
Your Datsun pickup.
It was just like you had wheels and no fenders, and then maybe some seats that were sort of sitting on something. You're like, wow, that car's kind of gone. But now, 10 years later, they're doing a better job of protecting.
Oh, absolutely.
Is it the underwater care?
Yeah. I mean, you don't really. I mean, these washes are nice, but it's really the protection that they put on them in the factory.
Oh, okay.
Thank you,
They're doing a
Mitch.
better
Thanks,
job.
Mitch.
Next.